Alright guys, so I am coming to you from Pounders Beach in Hawaii tonight, and I am sitting inside my rental car. Why inside my rental car, you ask? Well, because my children are already asleep inside of our rental apartment, and I don't want to wake them up with the exciting stuff that we're going to do with the sum and product of roots. So therefore, I'm out in the car. So, just a couple of questions we're going to try to look at today. You should have already learned about the how to get the sum and product of roots from a quadratic. You should have learned that the sum of roots, or in other words, alpha plus beta, where alpha and beta are the roots of a quadratic, is equal to negative b over a. And then you should have learned that the product of the roots is equal to, or alpha times beta, now this is for a quadratic of course, is equal to c over a. Now you should see in this situation that I could just then take negative b over a, b being 20, and then a being 25, so b is, negative 20, so I'd go negative 20 over 25, and then I'd put a negative in front. And then I should be able to reduce and get an answer of 4/5 would be the sum of the two roots. And then I could do c over a, so a, b, c, so c is 1 over a, which is 25, should give me the product of the roots. So I have the sum of roots here and the product of the roots here. So now this asks us to check our answer by solving the quadratic. I'm going to go ahead and pause it and work it out. You work out the quadratic on your own. So you can see that as I worked out the quadratic formula, I got 2 plus or minus root 3 over 5. Now if I do the sum and product of roots, we get just this. I got, when I add them together, of course, the radicals will cancel out, positive and negative, and I'll get 2 over 5 plus 2 over 5, which is 4 over 5. And then when I multiply them, I'll get the 2 times the 2, which is the 4. Then I'll get a minus 2 root 3 and a plus 2 root 3, which will cancel out. And then the root 3 times the minus root 3, which will give me minus 3. And 4 minus 3, of course, is 1 over 5 times 5 is 25. Therefore, it checks out. I get exactly the same thing by actually going through all the work to get the sum of the roots as I do the product of roots just by taking our shortcuts. All right, so I'm going to move on to the next one, now that you get an idea of how we'd actually use. All right, so now let's look at this this problem where we've got kx squared plus k minus 8x plus 1 minus k equals 0 has one root, which is 2 more than the other. All right, so let's go ahead and go through this problem. So we've got that a is going to be k. We've got that b equals k minus 8, and we've got that c equals 1 minus k. We've got alpha and beta, of course, and we know that one root is 2 more than the other. So we're going to say that alpha plus 2 equals beta, and that means beta will have to be 2 more than alpha. All right. Now, of course, the other things that we know are that the sum of the roots, or alpha plus beta, needs to equal negative b over a. We also know that the product, alpha times beta, needs to be equal to c over a. Now, negative b over a would be negative k minus 8 over k. And then c over a would be 1 minus k over k. Now, from here, we just need to do some normal row reductions, so elimination, substitution, whatever we need to do in order to be able to solve, because you'll note that I have 3 equations. Alpha plus 2 equals beta, alpha plus beta equals negative k minus 8 over k, and then alpha times beta equals 1 minus k over k. So at this point, it's just solving, all right, which is what we're going to go ahead and do right now. I know that beta is equal to alpha plus 2, so I'm going to put that into this one right here, giving me alpha plus 2 equals negative k minus 8 over k. All right. I'm also then going to take that and input it into this other one so I can get rid of the beta. So I'm going to have alpha times alpha plus 2 is equal to 1 minus k over k. Now, at this point, I need to go ahead and solve by eliminating one other variable. So let's just see what happens when we kind of put these together. Let's see if we can solve for alpha maybe in this top equation. If I can solve for alpha there, then I should be able to substitute. So that, when I simplify, is going to give me 2 alpha plus 2 equals negative k minus 8 over k. And I'm going to go ahead and distribute this negative in there because it's making me nervous. I feel like I'm going to forget it at some point. So I'm going to subtract the 2. So I'm going to have 2 alpha equals, and like I say, I'm going to distribute that. So it's going to be negative k plus 8 all over k, and then minus the 2 that I had, and then divide everything by 2. Now to simplify, I'm going to make this 2k over k so that I can put those together in one fraction, and that means that alpha is going to equal negative k minus 2k, so that'll be in minus 3k plus 8 all over k, and then divided by 2, so 2k, just like that. Now we'll go ahead and put that in for alpha in our previous right here. And so we'll have negative 3k plus 8 over 2k times negative 3k plus 8 over 2k plus 2 is all equal to 1 minus k over k. Now at this point, you can go ahead and put this into a calculator. You can do it by hand as well if you want, right? If we wanted to do it by hand, you would just take this and you would distribute it into both of those. At that point, maybe get rid of a common denominator by multiplying everything by the least common multiple. And then solve for k. You can do that if you need to by hand. If you have questions about how to do that by hand, please ask me. I'll help you out. Otherwise, just go ahead, try it out, work it out on your calculator, whatever. You should find that k is equal to 4. Once you have that k equals 4, you can go ahead and take that and you can put it into this one right here to find alpha. So that means that alpha will be negative 3 times 4 plus 8 all over 2 times 4. And that will mean that alpha is negative 12 plus 8, which is 4 over 8, which is 1/2. And then, of course, if, that will be a negative 12 plus 8, so that'll be a negative 1/2. And then, of course, that means if beta is 2 more, beta will be 3 over 2. Therefore, we've been able to find k and the 2 roots. All right, let's go ahead and look at one more question just because we like to, and why not? All right, so here we go. We've got if g and h are the roots of the equation. Now this is one similar to one that I've seen on IB exams before, so it's a good idea to kind of figure this one out. This one's a little bit difficult because it says if g and h are the roots of the equation x squared minus 6x plus 6 equals 0, what is the value of g squared plus h squared? All right, now like I say, this one's a little bit weird because it's difficult to kind of figure out how to work through it. So what we're going to do is we are going to do this. We're going to say, well, what if I start with alpha plus beta squared? Okay, now there's not a reason why you would come up with this other than the fact that you've seen it before, that you kind of can think in this way. So that's why I'm showing it to you now, so that it won't come as a surprise later. Because what I want you to see is if I take alpha plus beta squared, that becomes alpha squared plus 2 alpha beta plus beta squared. Now you may say, well, Mr. Bauer, that don't help me out. I say, well, yes it does, because now if I subtract 2 alpha beta the other side, what do I get? Well, I get on this side alpha squared plus beta squared, which is exactly what we want here, the 2 roots, the sum of the squares of the 2 roots. On this side, I'd have alpha plus beta squared, and then minus the 2 alpha beta. Now that's perfect because I already know how to get the sum of the roots and the product of the roots. All right, so the sum of the roots of course, from what we've been doing, is negative b over a. So in this situation, b is negative 6, so the sum of the roots would be negative b over a, which is negative 6 over a, which was 1. Okay, and then I'm going to go minus 2 times the product of the roots, which we know is c over a. Okay, so minus 2 times, and c, of course, is 6, and a is 1. And so at that point, I should be able to go through and finish the problem. Okay, so I'll have here negative 6 over 1, so that would be a 6 squared minus 2 times 6, and that's 36 minus 12, which is 24. I have therefore found that the value of g squared plus a squared is 24, even though I don't know what g is and I don't know what h is. Now, could you do that? Yes, you could. You could try to use the quadratic formula. You might find out that it's irrational. You might find out that it's imaginary. But no matter what, you would have to go through and do the solving, and then you'd actually have to do the squaring of the two roots and add them together. That process is going to be a lot longer and a lot harder than recognizing this pattern of the alpha squared and the beta squared related to the product of the roots and the sum of the roots, which is what we have here. All right, so that's all for this video. Just wanted to show you those, and now you should be ready to go to work.